So parametric equations are just another way of describing graphs in the xy plane. Only as the examples show, they give us a lot more information than just the equations that involve x and y alone. Let's do an example to see how they work. So let's sketch the curve given by x equals 1 minus t and y equals t squared for t going from -2 to 2. Okay, so t is called the parameter of the curve. X is essentially the equation that gives us the x coordinates of the curve. Y is the equation that gives us the y coordinates of the curve. These two together are called the parametric equations of the curve. So what we should start by doing is making a table of values to tell us what the x and the y coordinate are. So we want a t in our table, an x, and a y. T is going from -2 to 2, so let's just choose integer values there. So we'll use -2, -1, 0, 1, and 2. So let's find the x coordinate on the curve that corresponds to t equal to -2. So we have 1 minus t. 1 minus -2 is 1 plus 2, and that's 3. Y is equal to t squared. -2 quantity squared is equal to 4. So the point on the curve corresponding to t equals -2 is the point 3, 4. Okay, why don't you press pause while you plug each of these 4 remaining t values into x and y to find out 4 more points on the curve. So these are the remaining points that you should get by plugging in the proper t value to each of the x and the y. Okay, now let's graph the curve. So we'll start with the point 3, 4. Then we have the point 2, 1, 1, 0, 0, 1, -1, 4. So we see that what we actually have is a parabola. But as I said, there's a little bit more contained when we have parametric equations describing the curve than just its overall shape at the end. What we can do is we can put arrows on the curve to tell us the order in which the curve is traversed as t grows. Okay, so to see which direction we should draw the arrows, we have to see where the points go from -2 equal to t, then to -1, and so on. So when t is equal to -2, we were at the point 3, 4. That's this point. Then when t is equal to -1, we're at the point 2, 1, which is this point. So we see that the curve is generated in this direction as t grows. So we draw these arrows to complete our graph of the curve. Okay, so the arrows tell you the direction in which the curve is generated as t increases. Okay, why don't you press pause while you work on this example? So sketch the curve and put arrows on it to tell which direction the curve is generated. Okay, these are the coordinates of the points on the curve that you should have gotten. Now we want to plot them. Okay, so these are the points, and if we connect them, we just get a line. Or actually a line segment, because we're only going from 0 to 5. Okay, I didn't draw things to scale here, so it looks like it doesn't pass through that point, but it actually does. Okay, the last thing we have to do is put arrows on it. We see that for the smallest value of t, we're at the point -2, 3, which is here. Then as t grows, we get these remaining points. So the direction of the curve is this direction. Okay, so that takes care of it. Okay, the easiest way to graph curves described by parametric functions is to eliminate the parameter t. Okay, if we eliminate the parameter t, we're going to be left with the equation in terms of just x and y. Then for the direction, we could take care of that pretty easily. Okay, so let's eliminate the parameter t in these two equations. The easiest way to do it, in general, is to solve for t in one of the equations and plug it into the t in the other equation. So let's solve for t in this equation. Subtract 3 from both sides. We have y minus 3 equals negative t. Then divide both sides by negative 1. So we get negative y plus 3 equals t. And then we take this value of t and plug it into the t in the equation for x. So we get x is equal to 2t, so 2 times negative y plus 3 minus 2. So that says x is equal to negative 2y plus 6 minus 2, which is negative 2y plus 4. Okay, so now we just solve this for y, and then we get y as a function of x. So what we'll do is subtract 4 from both sides, and then we'll divide both sides by negative 2. So we get negative 1/2 x plus 2 is equal to y. So that right there is the equation in terms of x and y for the curve that we just graphed right there. Okay, why don't you press pause while you eliminate the parameter t here. The first thing is you should have divided both sides by 3, so we get t equals y over 3. Then we plug this value of t in for the t in the equation for x. And from there we get x equals 4 minus 2y. And now we just want to solve this here for y in terms of x. And we get that y is equal to negative 1/2 x plus 2. Okay, now let's graph this. Okay, so by graphing this line, we are graphing this set of parametric equations. So we'll start with the y-intercept, which is 2. Then the x-intercept is what we get when this is 0. And this is going to be 0 if x is equal to 4. So we get this line here. Okay, the last thing we need to do is we need to put arrows on it to indicate the direction in which the line is generated as t grows. So we'll just find out the point on the curve or the line that corresponds to t equals 0, and then find the point that corresponds to t equals 1. When t is equal to 0, x is equal to 4 minus 0, which is 4, and y is equal to 0. When t is equal to 1, x is equal to 4 minus 6, which is negative 2, and y is equal to 3. So the first point that we have is this point 4 comma 0. Then as t grows, we go over here to the point negative 2 comma 3. So that means that the curve is generated in this direction. Okay, curve, I can say curve for a line too. Curve is generic for a graph. Okay, one last thing I want to address is the fact that this is the equation for, this is what we get when we eliminate the parameter t for this set of parametric equations. But we see that it's exactly the same equation when we had this set of parametric equations. And so what that tells us is that for each curve, there are in fact lots and lots and lots of ways to describe it parametrically. Okay, here's one for you to try on your own. Press pause while you work on it. This time I'm going to solve for t in the x equation. Okay, so I get t is equal to x over 2, and now I plug that value of t into the t in the equation for y. Okay, we see that this is a parabola which opens upward and has a y-intercept of 1. To see how wide to make it, I'm going to plug in 2 and negative 2 for x. Okay, we find that when x is equal to 2 and negative 2, y is equal to 2. So then we can graph our parabola. And the last thing that we need to do is put a direction on it. So when t is equal to 0, we have x is equal to 0 and y is equal to 1. When t is equal to 1, we have x is equal to 2 and y is equal to 2. So that tells us that the curve is generated by going in this direction. Okay, and this parabola goes on forever. So for negative t, we're starting way out here. Then as t grows, we form the parabola in this direction.